Hi, I'm Shirin Fatai, a doctoral candidate under supervision of Professor Victor Mescherin in the Institute of Construction Materials, TU Dresden, Germany. Pumping is a transportation and casting method for concrete. The fact is, pumping concrete is a complex process. After finishing an AIF full-scale pumping project and facing challenges such as blockage, we decided to investigate deeper the generation of the so-called lubricating layer. It all begins with materials and device preparation. Next, the dry components are mixed in the mixer for a few minutes. Then the solution of water and superplasticizer is added to the dry components. By the end of mixing, 4 liters of concrete is discharged to obtain the constitutive mortar. Using tribometer, we are able to replicate the concrete pipe wall interface during pumping and measure interface viscosity and interface yield of concrete. With rheometry, the response of the material to imposed flow is measured. Here, we measure the rheological properties of the constitutive mortar. Using a sliper, we are able to replicate concrete flow in half a meter length pipeline. Here we measure the average pressure needed to pump with a specific flow rate, and during the test we increase this flow rate by increasing the coupled weight on the sliper. Meantime, we analyze the mortar composition to determine the water, sand and binder content in the constitutive mortar. Analyzing the result will help us to link particle migration, lubricating layer, the rheology of concrete and mortar, and finally the pumpability all together. Using model material, we are able to track the particles in the sliper using light sheet imaging. This will give us clearer understanding of what is happening exactly inside the sample, and later we can relate it to what is happening in concrete. We can improve the existing numerical model we have using computational fluid dynamic and ANSYS Fluent software. By the end of this project, we hope to have a deeper understanding of the particle migration in concrete during pumping and a more precise prediction of concrete pumpability.